today's topic is relation between electrical field E and electrical potential V. Right? Electrical field is indicated as V and potential is indicated as V. What is relation between these two electrical parameters, between these two physical quantities that we want to find out today? Right? Okay. So for that, we just now discuss equipotential surface. Right? What is equipotential surface? A surface at which potential at all the points remains same. Right? This is what the equipotential surface is. For example, let this is a charge, right? And this is my palm, for example. So comparatively all the points from the source at the same distance, potential at all the points remains same. That means this surface is called equipotential surface. Right? Okay. Now let me have two equipotential surfaces like this. Right? One is like, and second is arranged above the first one. Right? Okay. This is the first surface. This is the second surface. Perpendicular distance between both these surfaces is delta L. Perpendicular distance between two surfaces is delta L. Let me choose 2 points. Point A on the first surface and point B on the second surface. यहाँ पर दोनों points of interest are on the different equipotential surfaces. You getting my point, right? Okay. Again, एक ही potential surface होता है तो उसमें potential कहीं पर भी same होगा. But अगर potential surface change होता है तो उसका potential भी change होगा. You getting my point? That means potential remains same on the same equipotential surface, but it gets changed for the different equipotential surface. Right? For example, Q है यहाँ पर source charge. Let me imagine two shell A and B. A is at a R1 distance and B at a R2 distance. Here R1 is less than R2. Since potential V is equal to PQ by R, V is equal to, right? जितना डिस्टेंस ज्यादा होगा उतना पोटेंशियल कम होगा. ये हमने स्टडी किया है, राइट? सो इसमें से कौन से शेल पर पोटेंशियल ज्यादा होगा? विच इज अ क्लोजर वन, राइट? सो ए पर जो फर्स्ट है उस पर पोटेंशियल कंपैरेटिवली ज्यादा होगा देन द बी. यू गेटिंग माय पॉइंट, राइट? दैट मींस डिस्टेंस मायने रखता है, डिस्टेंस यहां पर मैटर करता है. ओके ओके. सी सो हम ये मान लें charges are arranging somewhere here, and due to those charges electrical field is prevailing in all the direction, right? Let this electrical field line is passing through these two equipotential surfaces in this manner, right? Okay, this is the electrical field direction, right? So जैसे आप source charge से दूर जाएंगे, जैसे distance change होगा, ऐसे सब potentials change हो गए. Okay, that means for two equipotential surfaces there is change in potential. जैसे एक potential surface से दूसरी potential surface पर आप move on हो गए, there is of course change occurs in the potentials, right? So potential of the first surface is let we assume V. So potential of the second surface when you move by delta L distance perpendicularly along the electrical field direction, potential it get changed, and this change is let delta V change in potential, and total potential is V plus delta V. Again, ये जो surface है equipotential surface उसका potential होगा V, which is relatively closer to the source here, right? And जो surface comparatively थोड़ा दूर है, जिसका distance ज़्यादा है, let the potential of this is V plus delta V. Clear, right? So potential at a point A is V. Potential at A is V, and potential at a point B on the other surface is VB is equal to V plus delta V. Got it? Right? Okay. Now, work done I want to find out. Let me have one unit positive charge on the first equipotential surface. Right? Unit positive charge है हमारे पास पहले potential surface पर, first equipotential surface पर. I want to move this unit positive charge from one surface to other surface. You getting my point? Then question arises in your mind that this charge is moved in which direction? in the direction of electrical field or opposite to the electrical field, right? So let me move charge from point A to point B, right? Okay, so what is electrical field in this area or in this vicinity? Is electrical field E, right? And how much distance will it cover while you bring this space charge from A to B? How much distance is this? Delta L, right? Okay, so work done is equal to what? Simply electrical field into delta L, electrical field E into delta L. This is the work is needed to bring unit positive charge. Again, unit positive charge. We do not take charge having arbitrary value, right? Unit positive charge from A to B. Then how much work done is electrical field multi how much distance you cover, right? Okay, question होगा कि वर्क की फॉर्मूला जो है W is equal to there is force into displacement. Here we use electrical field into displacement, right? Why there is not force? Because when you use unit positive charge, right, your force is converted into electrical field. ये कॉन्सेप्ट हमने क्लियर किया हुआ है. Got it, right? So instead of force we use electrical field here. Why? Because our charge is unit positive charge, it having value 1, test charge having value 1, that is why, right? Okay, so this is equation 1. Work done is equal to electrical field E into dl, right, or delta L, right? Okay, now according to our previous theories, when we move our charge from one point to the other point, right? Let these 2 points are A and B, for example, here A and B. Potential at A is VA and potential at B is VB. So potential difference between these two is say V, right? V is equal to what? VA minus VB. Again we have 2 points A and B. Potential at A is VA, potential at B is VB. You getting my point? I want to move charge from point A to point B. Then question arises in our mind that how much work is needed to done, right? So this work done is equal to the potential difference between these 2 points always. You getting my point? Again, when we have 2 points having 2 different potentials, then if you want to move charge from one point to the other point, then work must be equal to the, or work always be equal to the potential difference between 2 points. Got it, right? So here we move our charge from point A to point B. What is the potential at A is VA, and what is the potential at B is VB. Then how much work will be needed to move this charge from A to B is the potential difference between these 2 points VA and VB, right? So according to this concept, W, our work, is equal to VA minus VB. We have both this value, VA is equal to V and VB is equal to V plus delta L. So use those values here. V minus in the bracket V plus delta V get cancelled. What remains left? We have minus delta V. Why? Because this negative sign will associate with the second term in the bracket, right? So W is equal to what? Minus delta V. See, this is equation 1 and this is equation 2, right? The concepts are different, but the work done in the both the case will be same, right? So we compare both this work here. Compare कर दो उसको, right? Compare कर, so क्या होगा? E dot delta L is equal to minus delta V, right? Make a subject of electrical field and see what happens. E is equal to take this delta L in the opposite side, which is in a denominator of delta V. So we get E is equal to minus delta V by delta L. You getting my point, right? Okay. If we are not interested in direction and how, right? Then we can go with this relation also. Mode of electrical field is equal to mode delta V by delta L, which is a positive value, of course. Right? Okay. So, what is the physical interpretation of this relation? See, in a numerator there is delta V, numerator, right? What does it mean? Change in potential when you move from one point to the point. What is in a denominator? It's a change in length, delta L, right? So this is a ratio of change in potential to the change in length. What it tells us, when you move delta L distance, जब आप डेल्टा एल डिस्टेंस कवर कर रहे हैं तो उसमें पोटेंशियल कितना चेंज होता है? दैट मच ऑफ डेल्टा वी. You get my point? That means potential has changed, delta V. Change in potential per unit length, delta L. You get my point? So this is what the electrical field. Electrical field is nothing but change in potential per unit length. यहाँ से यहाँ हम जाते हैं तो उसके बीच कितना पोटेंशियल डिफरेंस है और उसके बीच कितनी दूरी है, कितना डिस्टेंस है, राइट? We have potential difference between 2 points. We have difference in a length, in a sense of distance, right? Then potential change in a potential per unit length gives us electrical field there, right? So E is equal to delta V upon delta L. So units का क्या होगा? Numerator में V है so volt, denominator में length है so meter. So volt per meter is unit, SI unit of electrical field. Okay, now this relation E is equal to delta V by delta L. This ratio is called potential gradient. What we call it is potential gradient. Again, potential gradient is nothing but it is simply change in potential per unit length. समझ में आया? क्या होगा? अगर ये लेंथ ज्यादा है तो पोटेंशियल चेंज ज्यादा होगा. अगर ये लेंथ कम है, if you place two surfaces close to each other, then potential change कम होगा. So change in potential is depends on the change in length. Distance कितना है 2 point के बीच. You getting my point? Right? Okay. This is just general form of the electrical field E and V, right? That is potential gradient का general form है. Okay. Now this is not mandatory and necessary that all the time you have electrical field in the direction of displacement, right? Suppose electrical field ऐसे है और displacement हम ऐसे करवा दें पर parallel, so ये general form मिलता है. But for example, our distance is in this direction, right? We want to move our charge from this point to this point, and electrical field is in the same way. Then both the directions are different. Then the effective component will take account, right? So for example, let we have displacement in x direction. Displacement in x direction, right? X. Then Ex is equal to electrical field in the x direction. This is called component of electrical field in x direction is equal to delta V by delta x, right? Let this displacement is in a y or in a z direction. Then which component of the electrical field we use is the component of y. Component of the electrical field in a y direction and component of electrical field in z direction. When you take component of electrical field in y direction, you have to take a displacement in the direction of y only, and similarly for z direction, you have to take a distance in a z direction only. You getting my point? So Ex is equal to delta V by delta x, Ey is equal to delta V by delta y, Ez is equal to delta V by delta z, right? These three components of electrical field we have Ex, Ey and Ez, and we know vectorially how we added those all components together. Electrical field, total electrical field is equal to Ex I cap plus Ey j cap plus Ez k cap. This is what the total electrical field in all the direction, right? Use this value here, we get like this. It is delta V by delta x I cap, delta V by delta y j cap, and delta V by delta z k cap. This is the total electrical field. E is related to the change in potential V. You getting my point?